Welcome to solverfy.
From the Smith Organic Chemistry textbook. And this problem is asking us to look at figure 27.2, which is the molecular orbitals of 1,3-butadiene. And we're asked to describe the molecular orbitals and make some comparisons between the number of bonding interactions and the number of nodes. And the comparison is between bonding orbitals and anti-bonding molecular orbitals. So looking at figure 27.2, we see that the first molecular orbital, psi1, has 3 bonding interactions. So I'm going to fill in this table that I've made as we go along. So psi1 has 3 bonding interactions. It has 0 nodes, and it is a bonding molecular orbital. So then, of course, psi1 is the lowest molecular orbital in figure 27.2. So moving up in the figure, we see that psi2 has 2 bonding interactions and a single node, and it is also a bonding molecular orbital. So we move up again, and we see that psi3 star is an anti-bonding molecular orbital. So anti-bonding. And remember, they do go from low to high like this because that is in terms of the energy levels of these molecular orbitals. So the first molecular orbital is the lowest energy, and they move up as the energy increases. So there is 1 bonding interaction in the third molecular orbital and 2 nodes. And again, as we said, it's anti-bonding. And then finally, the fourth molecular orbital, psi star 4, is also anti-bonding, and it has 0 bonding interactions and 3 nodes. Okay, and then the questions that we were actually asked in this problem are to make a comparison between the number of bonding interactions and the number of nodes. So for a bonding molecular orbital, which again 1 and 2 are, we see that for 1 we have 3 bonding interactions and 0 nodes, and for 2 we have 2 bonding interactions and 1 node. So we can say in the case of A, when we're looking at bonding molecular orbitals, there are more bonding interactions than there are nodes. So I'll put greater than sign there, so more bonding interactions than nodes. And then when we look at molecular orbitals 3 star and 4 star, which are both anti-bonding, we see respectively 1 bonding interaction and 2 nodes, and 0 bonding interactions and 3 nodes. So we can say that the opposite is true for the anti-bonding molecular orbitals. We can say that we have more nodes than bonding interactions. And when we stop and think about this in terms of what we're actually talking about, this makes sense, right? If it's a bonding molecular orbital, we would expect it to have more bonding interactions than we would nodes. Nodes represent repulsive forces rather than bonding forces. And we would expect the opposite to be true in an anti-bonding orbital, that we have more repulsion than we have bonding interactions. And that is what we see here. And that is the answer to chapter 27, problem number 2.